right. Is this on? 80s music, I love it. So today I'm going to tell you a little bit about scalability today and tomorrow. And maybe give you answer to this problem or maybe this issue. I've just been told that there is a difference between issue and problem. I didn't realize I consider everything a problem. That's a French bias. So I'm Jerome. I am the director for Consensys Solutions. That's a part of Consensys that deal with enterprise and public institution. Easy to find on social media. Reach out if you have questions about this talk. And I'm also the president of an association, non-profit called Assets. So if you want to learn more about Ethereum and you in France, reach out. It's a very nice place to learn about Ethereum. So why do we have discussion about scalability? I think the main reason is because we have adoption, and adoption is growing. So where we are in terms of adoption right now, we have 1 million active addresses since January the 4th. Active addresses means that the address has been doing transaction over the last week. And lots of addresses, unique addresses. And I've put this picture of a beer fork beer, because the price has been decreasing here. So when we meet journalists about Ethereum, they say like, whoa, the price is low. And like, well, the price is low, but adoption keeps growing and activity keeps growing. So it's a good sign that Ethereum, whatever the price might seem, whatever the bad news, the good news might pop up in the media, is still being used and being developed on more and more. And what we observe is that the capacity of Ethereum might seem a little bit jammed, maybe. So we have this chart here that indicates the number of transactions per day. We had a huge spike during the CryptoKitty rush. I think the guys from CryptoKitties are here. So thanks for stress testing the network. And since then, we are around between 800 per day or 1 million per day. So that's a lot of transactions, right? And if you compare the size of this number of transactions among other public blockchains, you realize that Ethereum accounts for, say, 3/4 of all the transactions that are appended in a public blockchain. And in terms of adoption among developers, that's growing pretty fast too. So if you ever want to develop a smart contract, you might be using one of our products called Truffle. Truffle is a smart contract testing tool, one of the most widely used smart contract testing tools. And it's been downloaded more and more. We are close to the 1 million mark. And last 3 months, we are up in 33%. The good people from Loom are also in this conference. And I want to shout out to them for providing the community with the Crypto Zombie tutorial. If you want to learn about coding on Ethereum, if you want to learn about using smart contract, Crypto Zombie is a very nice way of introducing smart contract to you. And we had, as far as I know, last time I checked, 250,000 people that finished this Crypto Zombie tutorial. And if you like security, which is very important when we talk about smart contract, you have the Ethernote tutorial. And each follow tutorial is a project by OpenZeppelin. And already 22K instances of their tutorial has been deployed. And also, of course, if you want to learn about Ethereum, you can also reach out to Consensys Academy. We have a training on Coursera right now. So what about scaling? Now we see not that we can realize that we have a lot of activity on Ethereum, maybe scalability is an issue. But before talking about scalability, let's make sure that we don't scale and in the meantime lose things that we might want to keep to stay a good blockchain. So what could be the good thing in a blockchain? As many nodes as possible. Short block time, fast finality, and also we would like the protocol to be cheap. And balancing between those three objectives can be quite difficult. Hence, the good thing about blockchain, it's decentralized. And decentralization is a very hard thing to define. 2 weeks ago, someone in the Token Economy newsletter wrote an article about it. Like maybe the best way to define decentralization is to say decentralization is the opposite of centralization. So myself, I like the definition of anyone willing to be a validator can become one. And being a validator requires reasonably low time and capital commitment. So applied to blockchains, that's my definition. And if you'd like to discuss this definition or suggest another one, please write to me. So the scalability debate is we want more transactions per second. But the blockchain cannot process more transactions than a single node can. And we don't want to compromise on the decentralization. So there is a naive approach, or sort of naive approach. Some blockchains have chosen this approach, which is the blockchain is a chain of blocks. If you want higher throughput, we just upgrade the size of the block and put more transactions in the block. Or maybe make more blocks per minute, so having a faster block. Or maybe both. But that's kind of hard to apply to Ethereum. So that's the story of Ethereum. Do you recognize it? That's everything big that happened on Ethereum. So we had Homestead, we had the DO attack, we had the DOS attack in Shanghai in 2016, we had the ICO craze, we had the CryptoKitty craze, and since then we haven't been able to upgrade the size of the block. So this chart ended in January, but you can check it out on Etherscan. It hasn't moved. Like it's stayed at 8 million gas per block. And if you want to put more gas, if we want to put more gas in each block, what might be at risk is that some nodes might not be able to compute and treat every block that they receive because it would be too big. So if you don't know, gas is a measurement of the difficulty to compute an operation in a block, in a transaction, and it ends in a block. So what can we do? Layer 1 versus layer 2. We can do things on the protocol level, that is upgrading the EVM. So the EVM is the virtual machine that every node is running, so as to make blocks bigger eventually. Or what we can do is upgrade the way the protocol behave by changing from proof of work to proof of stake, and maybe also changing the way that the data is organized in the blockchain, so sharding the chain. Or we can go off-chain for something, or use the security of the chain elsewhere. So that's more layer 2. Let's go. Upgrading the EVM. I hope you know this meme. It's a really good one. So the EVM right now is a stack machine, manipulated 256-bit items, which is kind of clumsy because the arithmetic is more optimized for 64 bits. And there is branching instruction. It's very complicated to optimize. That's a chart for the performances of some operation among different implementation of the EVM. So you have the GET implementation, which is called EVM. You have Parity, you have EVM to WASM, EVM JIT, and so on. So, you know, we can do better to get closer to native C++ eventually. Hence, one proposal that is using Ethereum 1.5. So that's upgrading the EVM. And in the next fork of Ethereum that will probably happen in January. It's being tested right now. We are going to upgrade the EVM to make it faster. And so this is being tested at the moment. So we can expect in the next months, once this fork has been implemented, to be able to upgrade a little bit the block size without threatening the decentralization of the network. So we're going to get something here. What we can do also is upgrading the EVM, changing the EVM to another implementation of the EVM. So there's a project going on since DEFCON 2, September 2016, that is implementing the EVM into WASM. WASM is a virtual machine called WebAssembly that's being developed by a lot of good corporations like Google, Microsoft, Apple, and so on. So it's supposed to be a very optimized virtual machine that can run a lot of different languages. And a team at the Ethereum Foundation is implementing the Ethereum Virtual Machine inside WASM. So that's the eWASM project. It's being in testnet since 2 months. So if you know the GET implementation, the implementation of Ethereum in Go, they have an eWASM project that is running. the C++ implementation of Ethereum, is also running this EWASM project. And recently, in March in Paris, we had the CTO of Parity, Frederick Harrison, that presented a nice talk where he managed to write a contract in Rust, deploy this contract on Ethereum, and interact with it. So one of the good things of switching from EVM to EWASM is that we get a lot of optimization, but also that we will be able to code smart contracts in any languages that will be recognized by WASM. Hence the fact that everybody was astonished that people have managed to write a contract in Rust, deploy the contract in Rust, and interact in the contract inside the Ethereum testnet called Rinkaby. So it's also compatible with other type of Ethereum clients. What we can do also is go off-chain. So if you have heavy computation that you need right now, you can go and have this computation done off-chain. And we already have solutions that are available right now. Some of them, you know them already, iExec. I won't do an introduction to this amazing project done here in Lyon. I think they have also a couple of talks in this conference, so if you want to get a deep dive into iExec, they are doing a tremendous job. One of their competitors, called Truebit, has a slightly different approach, and some projects have been running on Truebit with some success, notably the bridge between Dogecoin and Ethereum, called Doge Ethereum. It's running with Truebit. And overall, you have Oracleize. Oracleize is one of the oldest projects on Ethereum. So back in 2015, 2016, it was the application that was consuming the most gas. Now I think it's CryptoKitty, I'm not sure. But, well, still, it's been running for a while, and it's been running very well. You can provide to Oracleize with any API, also Wolfram Alpha knowledge engine, or you can provide with IPFS hash, Swarm hash, and you can pass them Dockers, and they're going to execute these Dockers and give you some proof of execution that AWS can provide, called TLS Notary. So if you have heavy computation, you can take this approach. It's working very well, it's well documented, it's very easy to implement in your smart contract. So you just make a request to Oracleize, and they bring the result of this request to your smart contract via transaction. Another approach that I like a lot is sidechaining. This is working already, but we have projects that are very ambitious in the ecosystem, notably Cosmos and Polkadot. Cosmos and Polkadot are interoperability protocols with slightly different approach. Cosmos like to hard spoon existing blockchains, which is replicating how this blockchain behave inside a Cosmos, in a Cosmos way, in Cosmos compatible way. And Polkadot is more focusing on doing a communication layer between those different protocols, so building bridges. And Parity, the team behind Polkadot, already have an approach that is usable right now. Cosmos is in beta, and Polkadot should be released in the Q3 2019. But already Parity has developed what we call Parity Bridge. So I want to tell you a bit about Parity Bridge, because that's something that my team has been using a lot recently. We've been commissioned by URP, Universal Reward Protocol, to help them architect their technical solution. And in order to get a lot of scalability into their project, to get a lot of throughput, we've been working on the Parity architecture, the Parity Bridge architecture. So Parity Bridge is a smart contract that is deployed both in your Ethereum main chain and in the Ethereum sidechain. The good thing about those two smart contracts that they can communicate and recognize that something has been interacting with them on one chain, or that something has been interacting with them on the other chain. So the main idea is that you have this Parity Bridge on the mainnet. You can deposit your ERC20 token on this Parity Bridge, and once the token has been deposited on your Parity Bridge, the other side of the chain can, for example, release some other ERC20 token, or even some other native Ether from the sidechain. So you can easily build any sidechain with a consensus algorithm that is already implemented in Parity. So if you like to have a sidechain on POS, Tendermint style, if you like IPFT, if you like POA, you can use it on Parity with your own Parity network, and then bridge it to the mainnet using your ERC20 token that you will have deployed on the mainnet as a form of stake, for example. And yeah, it's working pretty well. Some big projects like Swarm City or Givet are already using it. And we hope to have a lot of news on this project very soon. Competitors, POA network. That's pretty much the same as Parity Bridge, but they give a little bit of ease into implementing. So instead of developing a smart contract, you interact directly with POA network. And POA network is based with trusted US public notary. So you have our classic notaire in French that applied to be trusted third parties of the POA network for this sidechain, and you can deploy on this sidechain. Another way of sidechaining the throughput, or sort of sidechaining the throughput, is using state channels. And we have different implementations of state channels that are working very well already. Radon, Funfair, counterfactual, a generalized approach for state channel. And even if it's not safe for work, what SpankChain is doing in terms of state channel, and everything that they are doing in terms of state channel is open sourced, is really, really worthwhile if you want to check it out. It's working very well. And at Consensys, we are developing a project called Virtual Poker with sidechains, with state channels. And I think we are doing pretty good on this fight too. So if you have one single smart contract and you are afraid that the throughput on your smart contract will be too big, why not switch to state channel? It's a very good way of having everything off-chain but verified on-chain at any time. And yes, Plasma. I think Georgios already talked about this, so I won't deep dive into what Plasma is or how it works. So two main implementers of Plasma. So Plasma is also a generalized approach for side chaining, but instead of having your own chain, you have a Plasma chain, which is supposed to be much lighter to run. And you can use Plasma via Loom. So you can be a Loom validator with a stake of 100K at the moment. I think it's close to this number. And you can use the Loom SDK to implement, and it's pretty easy. And on the side of the competitor, you have Omizego. And Omizego has been one of the implementers for Plasma at first for doing payment, but they are also implementing solutions for ERC20 token, and will do generalized Plasma pretty soon. So finally, the one that everybody is waiting for. So when we got asked, when is Casper? The general answer is in 6 months, but it's been in 6 months for 2 years now. So one of the reasons why Casper has been so difficult to implement is that the specs have evolved a lot. So you can check on Ethereum Research, the website, and you see all the discussion, the different attacks, the different choice of architecture that they've considered, and they've switched to another one. And right now, the team of researchers that are working on Casper are pretty happy with the way that the specification is going to. And they said that it's 70% complete, so let's hope for the best. And since we've been waiting so long to implement Casper, the project has been switching to implement Sharding and Casper at the same time. Enter Casper. So the last specification of Casper, named version 2.1, can give you a comparison between what's possible on the current chain and what's theoretically possible in the current implementation version, the current specification version of Casper. So Eric Conner did some of those calculations. I verified it yesterday on the train. So trust me, if you divide the number of shards by the number of blocks and the number of blocks per minute and so on, you get to this amazing number of 13,000 transactions per second with only 1,024 shards. And an assumption on the number of on the block size that stayed the same. So without any optimization due to EWASM and due to the EVM, we stay at 1 million gas limit per block. And I think that's it. Yeah, I'm out of time anyway. Thank you, everyone.